What is this one gonna be? Social media out of everybody, the population. So this would be what? 338 over 530. So I want to compare, is social media more used by young people or social media used by everybody? So if I do social media by young people, 117 over 150, or 338 over 530. So this one is telling me that 78% of young people use it, and this one is telling me 63.8% of everyone use it. So what would you say? Is it used more by young people or more by everybody? More by young people. 18 to 34 are more likely to use social media than individuals in general because the 78% is higher. All right. Following data represents the number of drivers involved in fatal crashes. So if you're going to die in a crash, is there more likely a day that's higher to die in a crash? And is it more likely to die from a male on a certain day of the week than a female? So among Sunday fatal crashes, what is the probability that a randomly selected fatal crash is a female? Okay, so among Sunday fatal crashes, we want a female. So what word are we looking for? What would our fraction be, or what is our probability? What given what? The probability of a female given that she dies on Sunday. So what's my bottom number going to be? 6430. And my top number? 2287. So we're only looking at, our blinders are only looking at Sunday. How many females die on Sunday? Among females. Because you didn't like that one. So it says among Sundays, meaning we're only looking at Sundays. What is the probability that they're a female that die on Sunday? Among females, meaning, okay, we're only looking at females. Like if I said among the males in this room, what is the probability that they wear glasses? So among the boys in this room, what's the probability that they wear glasses? So meaning I only want to look at the males and see who wears glasses. So I only want to look at the day of the week, Sunday, and I want to see who dies female on a Sunday. This one, I only want to look at the girls who die on a Sunday. So this time, I am only putting my blinders on females. So this one is going to be the probability of Sunday given they are a female. So what is my fraction going to be? What's my bottom number? 13,989. So I am only looking at the female column. So that's the only thing I'm looking at is all my girls. And I want to know out of this column what number dealt with Sunday deaths. 2287. So two of these. So for the first one, it was Sunday and then female. And then for the second one, it was female and then Sunday. And then I've gotten it written pretty right there. All right. The more of these we do, the better off we get, the more practice you have. Suppose that you just received a shipment of 6 TVs and 2 are defective. So how many work?
2, 4, 3.
So if 2 are defective, which means they're broken, how many work? 4 work, okay? If 2 televisions are randomly selected, compute the probability that both televisions work. So that's question A. Compute the probability that both televisions work. So we have to find the probability that the first one works. Then we have to find the probability that the second one works, given that the first one works. Because you can't have the second one working given that the first one's broken. They both have to work. So if this one works, we have to say this one works given that that one still works. So, what's the probability that the first one works? What makes me happy over total? What makes me happy over total?
2/3.
How many TVs make me happy? How many work?
4.
4 work out of how many total TVs? 6. Yay? Now, what makes me happy over total? You have your TV that I gave you that works. How many total TVs are left?
5.
There are 5 TVs left. How many working TVs are left?
3.
We had 4 working TVs. And I gave James a working TV. So we now have 3 working TVs left. And we go to our calculator and we say, I have 4 working TVs out of 6 times 3. Thank you. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Times 3 working TVs left out of 5 total TVs left. There's my answer. Now, part B. What is part B screaming to us besides skip me?
1 minus.
It is screaming 1 minus. Now, if it says does not work, we're going to do 1 minus what?
Work.
Work. 1 minus 0.4 is gonna be 0.6. So if both of them works, then I do 1 minus one of the work, and that gives me the don't work.
So part A,
Is always gonna be part B's, the 1 minus.
okay,
Yep,
so that's the TVs left at work.
yep. That don't work.
0.4 don't work?
0.4 works.
That's what I thought. Okay.
Yeah, and when you do the 1 minus, that gives you the don't works.
Great.
All right, let's look at another one. There's my prettiness. I actually do this all the time when my husband or my daughter play music. I always think about the probability of what's the probability that this will play, or what's the probability that that will play. Suppose that a digital music player has 13 tracks or 13 songs. After listening to all the songs, you decide that you like 5 of them. With the random feature on your player, so everything can randomly come up, each of the 13 songs is played once in random order. So it can only come up one time, it can't repeat, it's not on repeat. Find the probability that among the first 2 songs played, you like both of them. Okay? So if we like 5 of them, how many do we not like? 8. If there's 13 total, and we like 5 of them, that means we don't like the rest of them, which is 8. Did everybody see what I did there? So what is the probability that you like both of them? So the probability that we like the first one times the probability that we like the second one, given that we like the first one. So what's the probability that we like the first one? 5 out of 13. Times
4, 3,
4 out of
12.
12. Because they cannot repeat. Sharon's not liking this. Once I play a song, it cannot repeat. And once I played the one that I like, there's only 4 more that I like. I did like 5. One of those good ones is gone. There's only 4 good ones left to play. Four good ones left. 12 total left. And we're staying away from the 8 bad songs. And when we do it in our calculator, we wrap them up. So when I go to my calculator, I'm going to do 5 over 13 times 4 over 12. So this is going to be the answer to the first one. Would this be unusual? No, because it is greater than 0.05. Are we good for part A? Sure we are, as long as Miss Cooper's doing it. Okay, that's the prettiness worked out. What is the probability that you like neither of them? Come on, y'all can do this.
So 1.
So the probability that I don't like it and the probability that I don't like the second one, given that I don't like the first one. What's the probability that I don't like the first one? Oh, I love y'all. Give me the next one. ugh. I told you, the more you do, the better it gets. And when I put that in the calculator, it is 14 over 39, or whatever the equivalent is. Give it to me. You got it?
1.5.
I could have scrolled down and got it too. But I just gave you the fraction. So we've done that we like them both, we've done that we like neither one of them. What if we like exactly one? Do what?
I was giving you the first fraction.
So y'all, let's think about it. We can either like both, we can dislike both, we can like and not like, or we can not like and like, right? Do we agree those are our four options? We can either like them both, dislike them both, like and not like and like. Yay? So we want to like exactly one of them. Do you agree that's going to be these two? Well, I just did this in part A, right? Like them both. And I just did this in part B, right? So if I know both of these, I can find this by doing what? 1 minus. So I found this in part A. I found this in part B. And this is going to be the rest of the story. So I'm going to do 1 minus part A minus part B. So I'm going to do 1 minus the likes minus the dislikes, and that's going to give me a like and a dislike, or a dislike and a like, which is hard to find. Yeah.
You wouldn't add the likes and dislikes?
If you put them in parentheses, then you would.
Yeah, I could do that. I could add up the likes and dislikes and then subtract them.
Okay.
Yep. Either way. Either way.
Okay,
Mhm.
I was just checking.
All right, so if I come up here, part A was 0.1282, 0.1282, 0.1282, and 0.359. So if I do 1 minus 0.1282 minus 0.359, this is going to represent the like dislike or the dislike like. Oops, I think I did it backwards. Dislike like. So if I know both the likes or both the dislikes, I'm going to take it away from one and I'm going to get the rest of the story. Ooh. Redo A through C and say, what if we can replay it? What if I get my favorite song and I can, hear my favorite song again? So for the first one, part A was the probability that you get a like and a like. But this time, they can be replayed. So what was the probability of a like? What was it as a fraction? How many could we like? 5 out of 13. But this time, they can be replayed. So would that 5 go down to a 4?
No.
It would stay a 5. And that 13, would it go down to a 12? It would stay a 13 because it goes back in the mix. So it would be 5 out of 13 times 5 out of 13. What would B be? It's the probability of a dislike and a dislike. So it would be 8 out of 13 times 8 out of 13 because it goes back into the mix. And then part C would be 1 minus this answer minus this answer. So you've got to take into account, so this one would be 5 over 13 times 5 over 13, 8 over 13 times 8 over 13, and then 1 minus this answer minus that answer. And then again, I have them written pretty down there. All right, let me let you try that one, 29. Don't do a tree diagram. Randomly selecting tulip bulbs that are both red. Brackets so that I don't have just a bunch of hours. So what they want us to do is find the probability that both are red, which means you want to know the probability that the first is red times the probability that the second's red given that the first is red. So what's the probability that the first one's going to be red? Who? Again, probability is what makes me happy over total. 12 over 30. So I pick a red tulip, I put it in my vase. And they didn't say replacement or not replacement, repeating or not repeating, but we have to know that if I pick the tulip and I put it in my vase, it's no longer there. So I go back to the garden and I look for another red tulip. How many red tulips are left?
11.
Reds that are left. 11. And how many tulips are left? 29. I go to my calculator, I wrap that up, and my answer's gonna be 0.152. Whoop whoop. Good? All right. There's my prettiness. I want to come look at this one. $30 tulips, 12 red, 10 yellow, 8 purple. I want a red tulip and then I want a yellow tulip.
I got it.
You're the man. For the moment. Impressive. I need to get harder. Sharon may hurt me. Probability is either one of those things you love very good or you hate. We know what side of the fence Sharon's on. The pages right there with her. Very good. Very good. Yes, ma'am. Yes, ma'am. So close. It's so far away. So close. All right. We want to go get a yellow tulip and a red tulip. So the probability that the first one is red times the probability that the second is yellow, given that the first one is red. So we go prancing to the tulip land, and we want to know what makes us happy over total. So what makes me happy is a red tulip. How many red tulips are there? 12 out of 30.
Yep.
We pick that red tulip, we put it in our vase, we prance back to tulip land. Sharon, how many tulips are in tulip land now? 29 tulips are in tulip land. And now what color tulip are we looking for? Yellow. And how many tulips are yellow? So there are 10 yellow tulips and there are 29 tulips to pick from. So it's 12 out of 30 and 10 out of 29, which gave you 0.138. So close. You didn't put that tulip in the vase. Good? All right, let's go for this one. What's the probability that the first tulip is yellow and the second tulip is red? The first tulip is yellow, the second tulip is red. Don't say anything out loud. Make sure you wrap up. What in the hell are you doing?
What was it?
Let's look at the
Oh,
problem.
it's purple.
Yes.
There you go. There you go.
Thank you.
I was looking at it, I was like, should I do this?
Yeah. Huh. Yeah.
Okay.
Yeah.
Great.
Hold on, give me your answer.